You're most welcome. Today we are going to look at action of a synapse. We are going to look at action of a synapse. Now we know that a synapse is a gap left when one neuron is meeting another neuron. So where one neuron is meeting another neuron, we can have what we call a synapse, but we can have also where a neuron is meeting a muscle end plate. That is when a neuron there is meeting a muscle end plate. Let me say like what we have in what we call neuromuscular junction. So where we have a neuromuscular junction, it means an axon or a neuron, that is a motor neuron, when it is meeting a muscle end plate. And meeting muscle end plate, then this is supposed to be motor. It's a motor neuron. Now where it meets that is also called a synapse. So we have two types of synapse. We have a nerve synapse where one neuron is meeting another neuron, then where we have a neuron meeting a muscle end plate or a muscle. Let us discuss the action of a nerve synapse. Now nerve synapse is supposed to work by promoting impulses from crossing from the presynaptic knob into a postsynaptic knob. That is, now here we shall not have a stimulus, but we shall have an impulse. Now when an impulse arrives on the presynaptic knob, it is going to depolarize the presynaptic membrane. After depolarizing the presynaptic membrane, it increases the permeability. Let me say, it ensures influx of calcium ions from the synaptic cleft into the presynaptic membrane, causing the synaptic vesicles to move and fuse with the presynaptic membrane. So the vesicles come around here. After the vesicles migrating to this position that is attaching on the presynaptic membrane, they are going to release the neurotransmitter substance by exocytosis, which can be acetylcholine or noradrenaline, which is going to move across the cleft. This is the cleft, the gap left there, and it attaches on the receptor sites that are positioned or that are located onto the postsynaptic membrane. So the receptor sites are not always present on the presynaptic membrane to ensure unidirectionality of information that is at a synapse. Now what is going to happen when the neurotransmitter substance attaches itself onto the receptor sites here? It can do two things. One, it can excite the postsynaptic knob, or it can inhibit. That's why we are going to look at two types of synapse. We can have excitatory synapse, then we shall have inhibitory synapse. Let's first discuss the excitatory synapse. Now when the transmitter substance attaches itself there, it's going to change the configuration of the membrane and it opens the sodium gates. When it opens the sodium ion gates, sodium ions from the cleft, they are going to enter into the postsynaptic membrane or knob here. Now when they enter inside there, it's going to increase the concentration of sodium ions, meaning, and remember, sodium ions are positively charged, meaning when they are positively charged, they are going to bring about what we call electrochemical gradient, which is going to be first suggested as the excitatory postsynaptic potential equal or greater than the threshold. With threshold means the minimum amount or minimum potential difference that is required to fire an impulse. After sodium ions entering, as they are entering, the neurotransmitter substance, that if it is acetylcholine, it is hydrolyzed there and then by choline styrase enzyme into acetyl and choline, and they are taken back into the presynaptic knob, whereby they will be resensitized or they will be rejoined again using energy from hydrolysis of ATP, which is formed in the mitochondrion or the numerous mitochondria present there. Now, when the excitatory postsynaptic potential is greater than the threshold, it is going to fire an impulse into the postsynaptic membrane, and there we shall have an impulse being generated. Then inhibitory, it works by inhibiting the flow of information, that is impulse, in the postsynaptic membrane, whereby when the neurotransmitter substance attaches itself here, it is going to open potassium gates and the chloride gates. When it is inhibitory, it does inhibitory effect. The configuration that is going to change, it is going to open the potassium gates, where potassium ions from the postsynaptic membrane is moved out into the cleft. That is, potassium ions is moved into the cleft, and the chloride ions from the cleft, they enter into the postsynaptic membrane. When the chloride ions, which are negatively charged, enter here, they make the membrane to become hyperpolarized. When the membrane becomes hyperpolarized, it means it cannot reach the threshold, it cannot generate an action potential, or we cannot generate an impulse, meaning this is going to be called inhibitory postsynaptic potential, which is going to be always below threshold, and there will be no production of an impulse